My name is Gerardo and I am a part of the Polymer Engineering Center. We are a research institute contained in the Mechanical Engineering Department of the University of Wisconsin Madison, and we specialize in traditional polymer processing techniques such as extrusion, injection molding, and thermoforming, but we also dabble heavily into the areas of polymer-based additive manufacturing technologies such as fused filament fabrication, vat photopolymerization, and big area additive manufacturing. Alright, so behind me, what we have here is what we like to call a big area additive manufacturing machine. And this works a little different to the 3D printers that you have probably seen in your school, or maybe when you've been to science fairs. And the reason why it's slightly different is, well, first of all, it's larger in size, and this allows us to produce parts that are bigger. And then second of all, this machine receives the material in pellet form as opposed to filament shape, which is what I have here. This has one major advantage, and that is that certain materials, due to X, Y, or Z reasons, are not ideal to extrude in filament form or spooling. Maybe they're too brittle or something along those lines. And so producing a material in filament form becomes essentially not an option. So what we end up doing is, if you have the material in pellets, you can circumvent that limitation and you can produce parts using a machine such as this one, where the properties of the material are not hindered by presenting the material in filament form. And so here at the Polymer Engineering Center, we have the fortune of having a variety of polymer processing equipment, and this plays really well with this type of machine because we can produce a material using our polymer processing equipment whose properties are tailored specifically to the final properties that are expected of whatever part we're going to be producing in this machine.
Hi, my name is Camila, and today we're going to show you the entire process that we have here at the Polymer Engineering Center to make pellets to then use it in 3D printers. So the process starts here with a twin screw extruder. So a twin screw extruder consists of two screws, something like this, that will be inside of this heated barrel, and the screws are going to be rotating, and in this case they are co-rotating. And the idea is for the polymer pellets to be transported from this zone all the way to the end, and it's going to be the friction between this and barrel that is going to be melting the polymer pellets. Now in this case, in this extruder, we have this hopper right here, which are going to be feeding the pellets with something like this. So if you see here, this is what we're feeding in the extruder. And then we're using also, we can use other components, in this case carbon black, that will give the material a very dark color, black color. And this twin screw extruder is usually used in industry to compound materials, and that's why we're using the two materials. Now the polymer will travel and it's going to be melted, and then it's going to come out here at the die.
Hi, my name is Gerardo, and I'm going to continue the explanation of our extrusion line process. As my colleague Camila was explaining, this machine here essentially mixes the carbon black and the pellets that we supply through the hopper, and makes it come out of this die with a circular shape in a very homogeneously mixed state. And so this strand that comes out of here is extremely hot at the moment. We're talking 250 degrees Celsius, and obviously we can process it like that. So what we do is we submerge it into a water bath where it's cool, and then it's transported to a machine that essentially consists of a rotating blade, and that allows us to chop the material into pellets again, because the 3D printer that we have here on the PEC is unlike the 3D printers you might have seen at your school. It doesn't work with filament, it works with pellets. And this has the advantage that if the material is too viscous or too brittle, you can't produce it as a filament. but you can process it as a pellet. So keep this in mind when we show you our special 3D printer in a couple of minutes, and you'll see why it's necessary to process it this way. Alright, so as the material comes out of the extruder that we just showed you, it comes out in this form of pellets that we can then bring this special 3D printer that we have here. This is essentially a larger version of the 3D printers you've probably seen everywhere else. The main difference, other than its large size, is that this 3D printer works by using a screw system. So you supply the material here in the form of pellets, and due to gravity it's going to go inside this contractor, and then this screw that's on the inside is rotating like this, and so due to the movement, the friction of the screw along the walls of the barrel that we have in here and the heat, the material melts and it's carried downwards through the screw all the way down until this nozzle that we have here, where the material can be extruded in a circular bead. We have used this 3D printer to produce all sorts of wacky objects that we can't make with either a traditional 3D printer or a normal extrusion process like the one we just showed you. For instance, a couple of years ago we had Engineering Expo, and the theme was Marvel's The Avengers, and so we 3D printed this hammer, and we'll show you a time lapse of how we did it in a bit.